Hi everyone. Today we will discuss differentiation, which is also called derivatives or the differential coefficient. So let us say we have a function y is equal to f of x. Now we want to calculate the differentiation of this function f of x, or we want to differentiate this y with respect to x because this is a function of x. So we can say we want to differentiate y with respect to x, or we simply want to differentiate this function f of x, or we want to calculate the differential coefficient of that. So what is this differentiation, or what is this differential coefficient? So let us just define this. So if a function is suppose defined throughout its interval, that is in all its real values, then the limiting value of the function such that limit of f of a plus h minus f of a upon h when this s tends to 0, that is termed as the differential coefficient of the function f of x at x equal to a. If we can calculate, we have this function f of x, and if we can calculate the limiting value of suppose f of a plus h minus f of a divided by this h when h tends to limiting value of this when this s tends to 0, then this is termed as the differential coefficient of the function f of x at x is equal to a, because x is replaced by a here. So we say that the differential coefficient of f of x at x equal to a is nothing but the limiting value of f of a plus h minus f of a upon h when this h tends to 0. So this is the basic definition as far as the differentiation is concerned. Now this is represented as f dash a because we have calculated the differentiation of f of x at x equal to a. So we will call it as f dash a. This is the prime notation here, and with the help of this prime notation, we represent the differentiation of the function. So it is f dash a. It is differentiated at a, so we call it f dash a. If it is differentiated at b, we will call it as f dash b, f dash c, and so on. Now here, this limit, when we calculate the limiting value of this may exist or may not exist. If it exists, then we say that the function is differentiable, and the differential coefficient of the function is nothing but the limiting value of this. If it does not exist, then we say that the function is not differentiable. Now, how it exists, whether it exists or not, how to test that? So for that, we calculate the left hand derivative as well as the right hand derivative, which we will see in the coming classes. So now, so depending on that left hand derivative, depending on the existence of this limit, in general, we can say, depending on the existence of this limit, we can say that the function is differentiable at any particular point in the interval of that function f of x, or in the domain of the function f of x. If it exists, this will be the value of the differentiation. If it does not exist, then there is no question of any differentiable value. So here, if you see, now here the different nomenclature. We call it as the derivative. We call it as derivative. We call it as differential coefficient. We simply call it as the process of calculating this limiting value that we have just seen. That is termed as the differentiation, and that is also considered as derived function. When we say derived function, so that will be used, this term derived function, it will be used only for the ordered pairs. Ordered pair means the f of x. We have this function f of x. Here x represents your domain. F of x represents its range. F dash x here, it will represent the differentiated part of it, or the differentiation of this. So when we write x and f dash x, means x represents a domain and f dash x represents a differentiated part. So if you simultaneously use this convention, then we call it as the derived function, because whenever we present function, so there will be the domain of the function, there will be the range of the function, and all that. So this derived function, we will use this word only when we use this convention, that is x and f dash x. Otherwise, it is termed as the differentiation, or it is termed as the differential coefficient, or simply the derivative. Now The process of finding the differential coefficient, that is termed as the differentiation. The process is termed as the differentiation. So if we say that differentiate f of x, suppose we are told or you are told that differentiate f of x, then in that case, if there is any likelihood of doubt as to which symbol is independent variable, differentiate f of x, suppose this is the problem, then we have to differentiate it with respect to some variable. So if we say that y is equal to, suppose, f of x, so y is representing what? This function f of x. F of x is nothing but the range of the function, where x represents the domain of the function. So which represents the variable. So if we have any kind of any doubt, then in that case we make it clear by saying some such thing as differentiate f of x with regard to or with respect to x. It means we are differentiating f of x or we are differentiating this y with respect to what? X. Suppose we have a function y which is a function of x as well as t. Let us say x represents the displacement and t represents the time. So it means y is a function of displacement and y is also a function of time t. It means here there are two variables. So with respect to which variable we want to differentiate it. So if we want to differentiate it with respect to x, it means in that case the t will behave as constant. If you want to differentiate it with respect to t, then in that case x will behave as a constant. But we can also differentiate y with respect to x as well as t simultaneously, but that is not part of your syllabus, so we need not worry about it. We have to consider calculus in one variable, so we don't have to consider two variable, three variable and all that. So if it is clearly known to us that y is to be differentiated with respect to x, we will consider this t as the constant. If we need to differentiate y with respect to t, then x will behave as the constant. So if there is any confusion, any doubt, then we can clarify using this statement that differentiate f of x with respect to or with regard to this x. So it means we will be doing this with respect to x, not with respect to any other term or any other terminology. Similarly, here the function f need not be defined for all real values of x. It is not necessary that this function y is equal to f of x is defined for all real values. It is defined from minus infinity to plus infinity. It is not necessary for differentiation to be calculated. If it is suppose defined only within this interval, let us say the function f of x is defined within the interval a to b, means the domain this domain x lies between a and b. And when we are differentiating f of x, it means in that case we will differentiating f of x within this domain or within this interval. So that will be termed as differentiation of that function within that interval. It is not necessary to conduct the differentiation or to calculate the differentiation or the differentiable derivable of this or derivative of this or the differential coefficient of this. We don't need that the function is defined throughout the interval, that is for all real values or from minus infinity to plus infinity. It can be within any particular interval and the differentiation will exist only within that particular interval if it is possible. So if you say derivable at any point, it means derivable at any point within that interval. Suppose you have a point C which lies between this A to B. It means we can calculate the differentiation at that point C, where C lies between this A and B. So these things are possible. So purpose here is that for differentiation of a function to exist, it is not necessary that the function should be defined throughout the interval, that is from minus infinity to plus infinity or for all real values. It can be for any particular interval and the differentiation will take place only within that interval. Now you can see this. It should carefully be noted that taking the limit, when we are calculating the limiting value of f of a plus h minus f of a upon h, when this s tends to 0, it means when we are calculating f dash f dash x at x equal to a, and f dash x at x equal to e means what? The limiting value of f of a plus h minus f of a upon h when s tends to 0 is regarded as a function of h, because here h tends to 0. So h is your variable. H is the variable, so this becomes the function of this h, because x is not there and h tends to 0. H is the variable here, so it is a function of this h. H is regarded as a variable and a is regarded as a constant here. Now, when we calculate the limiting value of this, that is limit s tends to 0 f of a plus h minus f of a upon h, it is convenient to write x instead of this a. So here we have this a. We have already understood that a is the constant and h is the variable. So instead of writing a, we can write it as x. And if you write this x, so we can consider the differential coefficient of f of x. That becomes limiting value of f of x plus h minus f of x upon h when this h tends to 0. So don't get confused that x is the variable. X is still behaving as the constant. H is the variable because we are calculating limiting value of this entire expression when this h tends to 0. Now, so if we try to find the limit involved in the definition of the differential, because these are the definition of the differential coefficient, that is the basic statement as far as the definition of the differentiation is concerned. Limiting value of this itself is termed as the derivative of the function or the differential coefficient of the function. Now, when we consider the limit involved in the definition of the differential coefficient by actual substitution, this is your actual substitution. We have replaced this x by a just for understanding. But function f of x, so if x remains in this, so that looks proper. That is the only intention here. The numerator and denominator both become 0 because here h is in the denominator, h tends to 0, and thus we get the meaningless form 0 by 0. So if we don't follow this, under that we will get this indeterminate form, that is also termed, it becomes meaningless as far as the algebra is concerned or as far as the algebraic solution is concerned. So that is termed as your indeterminate form. So just to avoid all these things, we can proceed considering this, and then to simplify such type of forms, to simplify such type of algebraic limitations, we have different method, and that we will be considering in the coming classes, how to solve when we get this form of the algebraic relations. Now here, there are various ways to represent the differentiation. We have the differentiation, or we want to calculate differentiation of f of x. So when we differentiate y with respect to x, so that is termed as dy upon dx. That is termed as your dy, the differentiation of y with respect to x, that is termed as dy by dx. Now when we consider dy by dx, so it means y can be replaced by what? F of x. So it is d of f of x upon dx. d of y upon dx. So d of f of x upon dx, or d of dx of f of x, d of dx of f of x, or d of f of x with respect to this x, or we simply write df x by dx. Here instead of writing f of x, we can write this f with this d. So df of x with respect to x. So we have df x upon dx, or we can also simply write f dash x or d of fx. So these are the various representations. D of fx, we have d of fx upon dx, d of dx of f of x, or df of x with respect to x. So these are the various representations. This is also f dash x. We have used the prime. We also write it as f1 x. This is also one of the representation. Okay, if we have suppose, so this is all first order differentiation. When we say y with respect to x dy by dx, it means we have differentiated y only once with respect to x. We can differentiate y with respect to x twice. We can differentiate it 3 times. We can differentiate 4 times. So that will be represented as dy by dx. If you differentiate it 2 times, it will be represented as d2y upon this dx2. Don't read it as d square y upon dx square. These are the symbolic representation for number of differentiation. So we have differentiated 2 times. It will be represented as d2y upon dx2. 2 times with respect to x. That's why this 2 does not represent the square, similarly cube or 4 like that. It simply represents how many number of times y has been differentiated with respect to x. So we don't read it as d square y upon dx square. We read it as d2y upon dx2. Similarly, if you differentiate it 3 times, it will be represented d3y upon dx3 and so on. So if it is suppose 2 times, so f dash x, it will be represented as f double dash x. If it is 3 times, f triple dash x. This can also be represented like this. First order differentiation f1x, second order differentiation f2x, third order differentiation f3x. So these are also the ways to represent the differentiation. The differential coefficient at x is equal to a. We are calculating differential coefficient in general throughout its interval, or differential coefficient at any particular point. When you calculate differential coefficient at any particular point, so it can be represented as f dash a. When we say f dash x, so this generalizes the interval, the domain of the function. We have differentiated throughout the interval. When we say value of the differentiation at some particular point, so that will be f dash a. Or again, differentiation f of x upon dx at x equal to a. Here we have mentioned x equal to a. You simply write this a like d f of x with respect to dx, and simply write it. It means that will also be understood that we want to calculate differentiation at x equal to a. There is no need to completely write x equal to a. If you write this a, that is also sufficient, and that will be d of f of a upon, after simplifying, whatever we get the differentiation, replace that x by a, and you will get the value of that differentiation at that particular point. Now here you can see these are just for your understanding. Must not think that df of x upon dx means dfx divided by dx. As I was saying, it is not the algebraic relation. It simply represents that y is differentiated with respect to x. Y or f of x is differentiated with respect to x. We have not divided this df of x upon dx. It's simply y is differentiated with respect to x. That is the representation or meaning here. Not means dfx divided by. For dfx and dx have no meaning. It has no meaning as far as the numerator and denominator is concerned. It simply represents what is the process going on. Means y has been differentiated with respect to x. To think so would be wrong as to think that log x is the product of log and x. When you write this y is equal to log of x, so it is not log into x. That is not. This is not any algebraic operation. It is just log of x, means the logarithmic function, the value of that x in terms of its logarithm, that represents this log of x. Similarly, when we say dy by dx, it means y is differentiated with respect to x. That is the only meaning. We are not dividing this y or d of y by this dx. So the confusion should not be there, and we should not read it as d square y upon dx square, d cube y upon dx cube. So all those things I have already discussed. So be careful when you are pronouncing all these things, and be clear as far as what the process is going on. We will discuss the derivatives or differentiation. So we will see what is the left hand derivative as well as the right hand derivative. So suppose we have a function f of x. If this function is defined over an interval, that interval can be any real number. It can be defined within minus infinity to plus infinity, or in a certain fixed interval. Suppose its domain is such that a less than x, x less than this b. So if the function is defined under certain domain, then under that domain or over that interval, what will be the right hand derivative and what will be the left hand derivative. So just to consider that, suppose we consider there is a very small number, suppose this h, where h is just a positive quantity. Now if you calculate limit of f of x plus h minus of f of x upon h when h tends to 0, if we calculate the limiting value of this f of x plus h minus f of x upon h when h tends to 0, and if it exists, then this is called the right hand derivative of the function f of x at x, and is represented as f dash x plus or f dash plus x. These are the representation only for the right hand derivative. Like suppose you have this function f of x. Now we have f of x plus h. Okay, where h is a very small and a positive quantity. So calculate the limiting value. So limiting value of what? F of x plus h minus of f of x upon this h, where this limit h tends to 0. Now if this exists, okay, if this exists, then this will be termed as the right hand derivative of the function f of x. Now that will be represented, either you can represent it as f dash x plus. X plus means it is in the higher side of this x, any greater than this x, whatever value of x you take under the domain of the functions, f dash x plus, or it can also be represented as f dash plus x, positive, that is representing the right hand derivative. So these are the representation, and it can simply be represented as f dash plus. This is also the way that we can represent f dash x plus, f dash plus x, or simply f dash plus. There is no need to always write this x plus or this x here and so on. So these are understood. So this is termed as the right hand derivative. Similarly, if you consider the limiting value of f of x minus h minus f of x upon minus h, here it is plus h, here it is minus h. So that we are now considering the left hand limit of this. So f of x minus h minus f of x upon minus h when this s tends to 0. Again, if this exists, then this will be termed as the left hand derivative of the function f of x, and this will be again represented as f dash x minus or f dash minus of x, or simply f dash minus. So this is your left hand derivative and this is the right hand derivative. So this way we define the left hand derivative of a function, right hand derivative of a function, and so on. Now the differentiation of f of x at a point, that was just the definition, how to calculate the right hand derivative and how to calculate the left hand derivative. Now what is the differentiation of the function f of x at a point? At a point, it means suppose the domain of the function is a less than x, x less than this b. This is the domain of the function f of x. So it means x lies somewhere between a and b. So we can say the function is differentiable in the entire domain a to b, or we can say the function is differentiable at a particular point. So if we need to calculate whether the function is differentiable at a particular point or not, then what are the conditions required which should be fulfilled. So if fx is said to be derivable at x, if f of x plus and f dash x minus exist and are equal. So we have calculated the right hand derivative and we have calculated the left hand derivative. Okay. Now right hand derivative and left hand derivative, if it exists, as we have just discussed, if the right hand derivative and the left hand derivative, if it exists and if they are equal, exist and are equal, then we say the function is differentiable at that particular point. Suppose you calculate the right hand derivative at c, the left hand derivative at c. When we say right hand derivative at c, it means c plus, and the left hand derivative at c means the c minus. Okay. Now if they exist and if they are same, then we will say the function is differentiable at the point c. So right hand derivative, left hand derivative, it should exist, and if they are equal, then we say that the function is differentiable at that particular point. So that is for the point. Now this common value is called the derivative of f of x at x and is represented as f dash x. Now we have the value of right hand derivative. When you solve this, limit h tends to 0, f of x plus h minus f of x upon h. Similarly, limit h tends to 0, f of x minus h minus f of x upon minus h. So we have calculated the right hand derivative and the left hand derivative. They have existed and they are equal. It means we got some point or some value. So that value is termed as the differentiation of the function f of x. That value will be termed as the differentiation of the function f of x at that particular point. So it means the differentiation of the function f of x is equal to the right hand derivative value or the left hand derivative value, because they are now existing and they are same. So any of this, because this and this it is equal, so the differentiation of the function f of x at that point x equal to c, if we calculate it at c, or if you calculate in general at x, suppose if x is any particular one, then right hand derivative whatever be the value, left hand derivative whatever be the value, obviously they are same because the function is differentiable. That value will be termed as the differentiation of the function f of x at that particular point, and that can be represented as this. For right hand derivative, we have used this plus sign, f dash x plus. For left hand derivative, you have used this. Now this value and this value is same, and that is the differentiated value of the function, and that will simply be represented as f dash x. So this is your f dash x. Now here again, if you see, in particular fx is said to be derivable at x is equal to a. Now let us consider a particular point x equal to a. So at particular point x equal to a point of its domain, limit s tends to 0, f of a plus h, as generalized we have represented as what? F of x plus h. Now we have taken a particular point in the domain of the interval f of x, and that point is suppose a. So f of a plus h minus f of a upon h. Similarly, the left hand derivative at that particular point, it will be f of a minus h minus f of a upon minus h. Now this is your right hand derivative at that particular point a. This is left hand derivative at that particular point a. If these two exist and if they are equal, then we will say the function is differentiable at x equal to a, and the value will be either equal to this or equal to this, and that will simply be represented as f dash a. So this is your value f dash a. So again, just to summarize this, we can simply represent, you have a function f of x. Okay. Now obviously this is a defined function, so it has its own domain. Now under this domain, we calculate the right hand derivative as well as the left hand derivative at that particular point. Let us say that particular point we take it as x is equal to a, where a is in the domain of the function f of x. So right hand derivative we have calculated at a, left hand derivative we have calculated at a. Now if this exists, if these two exist, and if they are equal, we say the function is differentiable at the point x is equal to a. It means in its domain, the function is differentiable at the point x is equal to a. So that is one part. Now what is the value of the differentiated function at x equal to a? So that will be equal to either this value of this, or it will be equal to value of this, because these two are same, and that will be represented as f dash a. So this is the value of the differentiated function f of x at x is equal to a. So this way we analyze whether the function is differentiable or not. If suppose right hand derivative is not equal to left hand derivative, we say the function is not differentiable. Differentiation exists if right hand derivative exists, left hand derivative. So right hand derivative exists, left hand derivative exists, but if they are not same, it means the function is not differentiable at that considered point or that particular point. But if they are same, then the function is differentiable at that particular point x equal to a, and the value of the differentiated function at x equal to a, it will be f dash a. Now, so we have considered differentiation at any particular point. We have the domain of the function. Under that domain, we have taken a point and we have just observed that how the differentiation at that particular point is to be calculated, how it is to be tested, whether the function is differentiable at that particular point. As far as the testing is concerned, you have to calculate the right hand derivative and the left hand derivative. If they exist and they are same, it means the function is differentiable at that particular point. Now, how to check the differentiability of a function in an interval? So that was for a particular point. Now let us say the entire interval of that function or any particular interval of the function in its domain. So fx is said to be derivable on an interval if it is derivable at each and every point of the interval, and that is obvious. If it is derivable at each and every point of that interval, obviously we will say that the function is derivable in its entire interval. Now fx is said to be derivable on the closed interval AB. Let us say we have this particular closed interval AB. If for the points A and B, f dash A plus and f dash B minus exist. You see this. We have this closed interval AB. When we say A plus, this A plus yani any point greater than this A. When we say B minus, any point less than this B, it means all these points A plus or B minus that lies within this interval A and B. Within the interval A, it should be greater than A, this extreme point A, and it should be less than this extreme point B, so that these points considered lies within the interval AB. And for any point C such that, now take any point C which lies between this AB, which lies between A and AB, then f dash C plus and f dash C minus, if it exists and are equal, then we say that the function is differentiable throughout the interval AB. Throughout the interval AB. For the points A and f dash A plus A, it should only exist. F dash B minus, at this extreme point, it should exist. Okay, it is not necessary that they should be same. Only extreme points are A and B under this closed interval. A plus exists, differentiation at A plus, and any point greater than this A, it should exist. Any point less than this B, it should exist. Okay, if this condition is satisfied, then take any point C lying within the interval A and B. If at that point C, f dash C plus means the right hand derivative at C exists, left hand derivative at C exists, and if they are same, then we say that the function is differentiable throughout the interval A to B. So again, let me clarify this. Suppose you have this closed interval AB. The function f of x is defined in this closed interval. Calculate f dash A plus. F dash A plus. And suppose it exists. Similarly, calculate f dash B minus. And say it exists. Okay, so this condition is satisfied. These two conditions are satisfied. We have taken a point A greater than this A. Okay, we have taken a point less than this B. We have calculated the differentiation at that particular point, either this A plus or this B minus. And suppose both exist. You need not check whether they are same or not. Both exist. That existence should be there. Then take any point C lying in this interval. A less than C, C less than this B. C somewhere between A and B. Now check the right hand derivative and the left hand derivative at C. It should exist and they are same. So if they exist as well as they are equal, then we say that the function f of x is differentiable throughout the interval this A to B. Throughout the interval A to B. So this is the condition that we check the differentiability of a function between any interval. Particular point we have already seen. Throughout the interval, we have to consider these two conditions. Existence of f dash A plus, existence of f dash B minus, as well as existence of differentiation at the point C. It means it should exist as well as it should be equal. The left hand derivative as well as the right hand derivative, it should be equal. If these conditions are satisfied or justified, then we say the function is differentiable throughout the interval a to b. So now let us take some example. So suppose the first example, if you can take, find the derivative of the function f of x equal to x minus 1 upon 2x square minus 7x plus 5 when x is not equal to 1 and is equal to minus 1 by 3 when x equals 1. So here f of x is x minus 1 upon 2x square minus 7x plus 5 when x not equal to 1. Just because if you factorize the denominator here, we will get x minus 1 upon x minus 1, 2x minus 5. Now this function is not defined at x equal to 1, and that's why we say that the value of the function is this when x not equal to 1, because it is in the indeterminate form, that is 0 by 0. So it is not defined at x equal to 1. So excluding 1, we have the definition of the function or value of the function f of x as x minus 1 upon this. Now this x minus 1 can be cancelled out when we say that x is not equal to 1. So under this condition, these two factors, numerator and denominator, x minus 1, it can be cancelled out, so that we have f of x equal to 1 upon 2x minus 5. So this is the value of the function f of x equal to 1 upon 2x minus 5 when x is not equal to 1. And if you put f of 1, this value, so that is already given that the value of this function at x equal to 1 is minus 1 by 3. So we know f of 1 is minus 1 by 3 and f of x is 1 upon 2x minus 5 when x not equal to 1. Now let us proceed further to get the differentiation of this. So if you consider the right hand derivative at 1, so right hand derivative at 1 means f dash 1 plus, as we were discussing. So that will be equal to your limit. We are calculating at 1 plus. In the x or a here, it is 1. So limit h tends to 0, f of 1 plus h minus f of 1 upon h. So that will be equal to limit h tends to 0, 1 upon 2h minus 3 minus of 1 by 3. How it is there? So that you can just see. F of x is 1 upon 2x minus 5. So this x has to be 1 upon 2x minus 5. So this x has to be replaced by what? 1 plus h. So when x is replaced by 1 plus h in 1 upon 2x minus 5, you will get this relation. So substituting the value of x or replacing x by 1 plus h in the value of f of x, you will be able to get this. So substituting the value here, so this becomes your 2h. Taking LCM and simplifying, we are getting 2h upon 3, 2h minus 3 into h. H tends to 0, so this will be equal to minus of 2 by 9. Because this h and h here, it will get cancelled. So it is twice of 3, 2h minus 3, putting h equal to 0. So 2 minus 3, that is minus 1. So it becomes minus of 3. So finally, it is twice of minus 3 into 3, and that is minus of 2 by 9. I hope this is clear. Similarly, left hand derivative. So when we calculate left hand derivative, so again it will be limit s tends to 0, f of 1 minus h minus f of 1 upon minus h. Again replacing how much? X by 1 minus h in the value of this. That is f of x is equal to 1 upon 2x minus. Now we are taking f of x equal to 1 upon 2x minus 5 because this is the value of the function when x is not equal to 1. And when we consider the right hand derivative or the left hand derivative, it means we are not considering x equal to 1. We are considering either x equal to 1 plus or we are considering 1 minus. So this is value for x equal to 1 plus or 1 minus, because this is the value when x is not equal to 1. That's why it is either 1 plus or it is 1 minus. So again replacing all this, you will get replacing x here by 1 minus h and simplifying, again we are getting this as minus of 2 by 9. So right hand derivative we are getting minus 2 by 9. Left hand derivative also we are getting minus 2 by 9. So right hand derivative exists, left hand derivative also exists, and they are finite. And we observe that right hand derivative is equal to left hand derivative, and that is equal to minus 2 by 9. That's why the differentiation of the function is minus 2 by 9, means f dash 1 differentiation at x equal to 1, that is minus of 2 by 9. So this is the value of the function, and a differentiated function f dash x at x is equal to 1. So finally we are getting this value. Now in this question, if you consider, we have f of x plus y. F of x plus y is equal to f of x plus y is equal to f of x into f of y. F of x plus y is equal to f of x into f of y. So now see the next question. Here, let f of x plus y is equal to f of x into f of y for all values of x and y. Now we have f of 5 is equal to 2, f dash 0 is equal to 3, and f dash, so we have to find value of f dash 5. Value of f of 5 it is given, f dash 0 it is given. We need to calculate value of f dash 5. So here, if you consider f of x plus y, this is the given relation. F of x plus y is equal to f of x into f of y. Now if we put y is equal to 5, because value of f of 5 it is given, so if we put y is equal to 5 in this given relation, so we will get f of x plus 5, that is equal to f of x into f of 5. This is just from the given values. F of x plus 5 is equal to f of x into f of 5. Now we are just trying to calculate all these values, so that we need to calculate this f dash 5, and that in that calculation we will need similar values. So f of x plus 5 is equal to f of x into f of 5. Now f of 5 it is equal to 2. That is also given. F of 5 is equal to 2. So f of x plus 5, that will be equal to how much? Twice of f of x, because f of 5 it is given as 2. So this becomes your twice of f of x. So f of 5 plus h, it is equal to twice of f of h. F of 5 plus h, that is equal to twice of f of h, because here when we simplify we get twice of f of x. So just by replacing x by h, we can write f of, we have replaced this x by 5 here, okay, and y it is h. So f of 5 plus h, that will be equal to twice of f of h. So now this relation is available with us. X has been replaced by 5. So here also x will be replaced by this h, because y is now replaced by h. So from the definition of the differentiation, as we have discussed in the previous cases. So from the definition of the differentiation, that is f dash 5, it will be equal to how much? Limit h tends to 0, f of 5 plus h minus f of 5 divided by. This is from the definition of the differentiation. So this will give you limit h tends to 0, f of 5 plus h equal to how much? Twice of fh. So it is replaced as twice of f of h minus f of 5, it is already given, and that is equal to 2. So it is minus 2 divided by this h. So this gives you f dash 5, because this is differentiation at x equal to 5. So f dash 5 is equal to twice of, taking this 2 common, limit h tends to 0, f of h minus 1 upon this h. Now if we put x equal to 5, so now we have this relation. Okay, we will use this relation in our further calculation. Now if we put x equal to 5 and y is equal to 0 in the given relation, x is equal to 5 and y is equal to 0 in this. Now see what happens. So f of 5 plus 0, 5 plus 0, that will be equal to f of 5 into f of 0, f of 5 into f of 5 into f of 0, because y is replaced by 0, x is replaced by 5. So from here we are getting, this becomes your f of 5. So to f of 5 into f of 0. F of 5 is equal to f of 5 into f of 0. Now, and f of 5 is equal to how much? 2. So if we replace this by 2 and 2, so this 2 will get cancelled. So that we can observe here. Okay. So from that we are getting f of 0 is equal to how much? 1. Because that you can see. F of 5 that will be cancelled because this is equal to 2. So f of 0 it is equal to 1. So we got the value of f of 0. Now from the equation that we have just considered, and this value of f of 0 is equal to 1, we can say f dash 5 is equal to twice of limit s tends to 0, f of h minus f of 0 upon h, because here it is 1, and that 1 in the previous equation, here it was 1, again you can see it, here it is 1, okay, this 1, we got f of 0 is equal to how much? 1. So that 1 can be replaced by f of 0. These things are considered just to bring the similarity in the equation. So this f1 it is replaced by f of 0. So now we have f of h minus f of 0 upon this h. And f of h minus f of 0 upon this h, that is equal to how much? Twice of f dash 0. This is twice of f dash 0. This is your, if you consider only this part, this is nothing but the differentiation of the function at x equal to 0. F of x minus this f of 0 and divided by this x. So this becomes your differentiation at x is equal to 0. So this entire quantity is replaced by f dash 0. So twice of f dash 0. So f dash 5 is equal to twice of f dash 0. But f dash 0 it is given in the question, and that is equal to 3. So it is twice of this 3, and twice of 3, that makes it 6. So f dash 5 it is equal to 6. So from this way we can calculate the value of f dash 5. So sometimes when we calculate the differentiation of the function, we need to consider the definition of the differentiation, and that is the left hand derivative, the right hand derivative, and from there we can proceed further and we can calculate differentiation of such type of functions. So there are certain other methods that in the coming lectures we will see all those relations and all those methods.